Hey, this is Farhan here. Today I want to give some answers of some specific questions about vector. So the first question is, what is a vector? A vector is a quantity or phenomenon that has two independent properties, magnitude and direction. The term also denotes the mathematical or geometrical representation of such a quantity. Examples of vectors in nature are velocity, force, electromagnetic fields, and weight. Weight is the force produced by an acceleration of gravity acting on a mass. A quantity or phenomenon that exhibits magnitude only, with no specific direction, is called a scalar. Examples of scalars include speed, mass, electrical resistance, and hard drive storage capacity. Number 2. What is vector space model and why do you use in information retrieval technology? Vector space model or term vector model is an algebraic model for representing text documents and any objects in general as vectors of identifiers, such as, for example, index terms. It is used in information filtering, information retrieval, indexing, and relevancy rankings. Its first use was in the smart information retrieval system. Information retrieval is great technology behind web search services. In information retrieval, it is common to model index terms and documents as vectors in a suitably defined vector space. The vector space model is one of the classical and widely applied retrieval models to evaluate relevance of web page. The retrieval operation consists of computing the cosine similarity function between a given QD vector and the set of documents vector and then ranking documents accordingly. Number 3. Support or argue on the assertion that says vector space model faces a lot of drawbacks in information retrieval model. For this question, no, I don't support on the assertion that says vector space model faces a lot of drawbacks. Because one of the main advantages of vector space model is that we can make it more complex without complicated calculations. So when we start working with millions of terms and millions of documents, so the solution will be to add weights to terms while indexing. There are many ways to weight the terms in a document, but a good example is to weight the terms by percentage of relevance. For example, say you were indexing an article that says about different fertilizers that mention special types of fertilizer for daisy and roses. We certainly want to signify rose and daisy as important terms for the document. The term should certainly carry more weight. Instead, we might want a vector that tells us 80% of 8 or 1, 1, where the vector tells us 80% of article pertains to fertilizer while 10% did. On the other hand, drawback means a disadvantage or the negative part of the situation. That's why, for this question, I don't support it. Number 4. Using the results of the previous projects, Loon, Heap, and Zipf's law, term and document occurrence project, and inverted index project, and TF-IDF column, to have a new table containing columns of terms, document, term occurrence, and term frequency. The TF-IDF should be calculated by the rapid manner. Okay, for this question, I have chosen 25 words from my text processing to show the result. I will use the rapid manner to show the whole process over here. I uploaded my 10 documents on the rapid manner, choose the term frequency. After that, I choose the term occurrence and the TF-IDF. I run it and I have the result. Okay. Number 5. Construct a new table for terms and individual documents for your 10 documents used in term and document occurrence project and inverted index project. Select a single column to make it a query column using cosine similarity shows which document among the remaining 9 documents is very close to your query document. Note that you can do it manually or by using rapid manner. Whichever way you use, kindly send the files attached with all of your working procedures. Okay. For the cosine similarity, you can easily use the rapid manner to calculate it. So for this, go to the rapid manner. First, use the text processing that you have used for your 10 documents. After that, go here, type similarity, data to similarity, this option, drag it over here, connect the first line, and for here, for the data similarity, you have to make some changes. The measure type should be numerical, and the numerical measure should be cosine similarity, because we want to have the calculation of the similarity. Okay, run it. Okay, after run it, it will show the similarity over here. It will calculate each and every document similarity. For example, the first document and compares to the second document over here. So the similarity is this one, 0.739. So it will calculate each and every document. I have included the whole result over here. For the question, for this question, I have to choose one of my document as my query document. So I've chosen the first document as my query document. As you can see, the document 5 is the closest document to my first document. So I have written here that document 5 is very close to my query document. Thanks for watching this video.